Hi, welcome to my channel. In this video, we want to solve the following problem. In right triangle ABC, with angle A equals 90 degrees, angle C equals 3 alpha. Point D is on AC such that angle DBC equals alpha. Given that BD equals 11, DC equals 4, and AD equals x, the goal is to find x. And now for the solution. First, consider triangle BCD. From D, construct DP with P on BC such that angle DPC equals 3 alpha. Since angle DPC equals angle PCD equals 3 alpha, triangle DPC is isosceles, so DP equals DC equals 4. Now, angle DPC is an exterior angle of triangle BPD. Since an exterior angle equals the sum of interior opposite angles, angle PDB equals 3 alpha minus alpha, which equals 2 alpha. Next, from P, construct PQ with Q on BD such that angle PQD equals 2 alpha. Since angle PQD equals angle QDP equals 2 alpha, triangle PQD is isosceles, so PQ equals PD equals 4. Similarly, angle PQD is an exterior angle of triangle BPQ. By the exterior angle theorem, angle BPQ equals 2 alpha minus alpha, which equals alpha. Since angle QBP equals angle BPQ equals alpha, triangle QBP is isosceles, so BQ equals PQ equals 4. Then QD equals 11 minus 4, which equals 7. Next, drop PR perpendicular to QD with R on QD. In isosceles triangle PQD, the altitude from the vertex bisects the base, so RD equals 7 over 2. Next, consider right triangle PRD. By Pythagoras theorem, PR square plus RD square equals PD square, or PR square plus 7 over 2 whole square equals 4 square. Therefore, PR square plus 49 over 4 equals 16, so PR square equals 15 over 4, and PR equals square root 15 over 2. Since tangent 2 alpha equals PR over RD, we have tangent 2 alpha equals square root 15 over 2 divided by 7 over 2, and so tangent 2 alpha equals square root 15 over 7. Returning to our original diagram, consider angle BDA, which is an exterior angle of triangle BCD. By the exterior angle theorem, angle BDA equals alpha plus 3 alpha, which equals 4 alpha. Now, consider triangle BDA. By Pythagoras theorem, AB square plus AD square equals BD square, so AB square plus X square equals 11 square. Therefore, AB square equals 121 minus X square, and AB equals square root 121 minus X square. Next, let S be on AB such that DS bisects angle BDA. So angle BDS equals angle SDA equals 2 alpha. Let SA equals L. Then BS equals square root 121 minus S square minus L. Since angle BDS equals angle SDA equals 2 alpha, we apply the angle bisector theorem to triangle BDA. Given a triangle with these dimensions, the theorem tells us that A over B equals P over Q. By the angle bisector theorem, S over 11 equals L over square root 121 minus x squared minus L. Cross multiplying gives x square root 121 minus x squared minus xl equals 11L. After moving xl to the right hand side and factoring the right hand side, we obtain L over x equals square root 121 minus x squared over x plus 11. Next, consider right triangle DAS. Tangent to alpha equals AS over AD, so tangent to alpha equals L over x. Since L over x equals square root 121 minus x squared over x plus 11, we have tangent to alpha equals square root 121 minus x squared over x plus 11. But we found tangent to alpha equals square root 15 over 7 earlier, so square root 121 minus x squared over x plus 11 equals square root 15 over 7. Squaring both sides gives 121 minus x squared over x squared plus 22x plus 121 equals 15 over 49. After cross multiplying, we get 5929 minus 49x squared equals 15x squared plus 330x plus 1815, which reduces to the quadratic equation 32x squared plus 165x minus 2057 equals 0. Using the quadratic formula, with a equals 32, b equals 165, and c equals minus 2057, gives two possible solutions. S equals 187 over 32, or s equals minus 11. Since x is positive, we have s equals 187 over 32, which is the answer. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.